Welcome to the Crazy Hat Chemist. So another video in bonding and molecular structure. Bam! So the resonance structures of ozone. First, you got to get the formula for ozone, and that is O3. Hopefully you got that. Now I want you to do a Lewis dot structure for ozone. That's right. There's one of them. And here is another one. Actually, there are two more if you want to be absolutely precise. And here is why. Okay, the two more are just like these two, except that the lone pair of electrons is below the plane instead of above the plane in which I have drawn it. That is, that double bond is non-rotational because it has pi electrons above it. And that lone pair of electrons can either be above or below. So there's a total of 4 Lewis dot structures that are resonance structures for ozone. Now, are there any predominant resonance structures? That's the question. So let's figure out a few more little bits of information about this. First, they are both, or all 4 of them, are AX2E. There are 2 bonding, 1 non-bonding. It is a bent or bent molecule, and that is much less than 109.5, more close to 105 degrees. This molecule is polar because it has polar bonds, yes, because of those electrons, but it is certainly asymmetrical, therefore it is polar. By the way, a Lewis dot structure that is a triangle does not work. That has been shown to be experimentally not true. Okay, so if you drew one that was a triangle, that one is not correct, even though the formal charges on that one are the best. But that has been shown to be not experimentally proven. So, and the reason is because triangular structures are sterically inhibited. That means that the atoms are very too close together. You really need to get into 5 and 6 membered rings to be sterically non-hindered, and the atoms to be far enough away as possible that are reasonable. Anything larger than that, they start to fold on each other. Anything smaller than that, they're bumping into each other as far as the electron clouds. All right, just another note off to the side. Okay, let's get the bond order of this, and there are 3 bonds and 2 regions. So that's a bond order of 3 halves. That lets you know that each one of these bonds here on each of the outside oxygens between the central and the outside oxygen is like a bond and a half. No way. That means that there are no double bonds, there are no single bonds. Bond order, baby. Okay, and we're going to get the formal charge. Formal charge here of -1 and a +1 in the central atom. And a 0 for that outside. And then the right-hand structure, a 0, a +1, and a -1. So, which one is the predominant structure? In fact, if you were to do the other 2 Lewis dot structures here with the lone pair of electrons below the plane, you would get the same formal charges. So that's why I'm not including those here. Which one is the predominant? Which one has an octet? They both have octets. Which one has the most negative formal charge on the most electronegative element? They're all the same element, for goodness sake. So, that is, these are equivalent resonance structures. The formal charges are equivalent on all of these. Notice that the formal charges sum up to 0. That's why this molecule has no charge to it. Okay, all right, so this picture right here does a better representation of the ozone molecule. Okay, and that is there's a positive formal charge on that central oxygen, and the single bonds with the dashed lines are representing that 3 halves bond order, or a bond and a half. Okay, and those oxygens on the outside there have a negative formal charge. Okay, all right, hopefully that makes sense. And on this one here, it depends on where those lone pairs of electrons are, but we got a bond angle that is very unusual, and that is because this molecule is quite unusual. Ozone. Now, this is going to be the 3rd hair day here for me, and you're going to let me know which of these 3 hairs is your favorite. The green, the red, or the platinum blonde. You let me know which one is the best hair. You know, when I get really old, my goatee might look like this color. Give me a thumbs up if you like that video. Subscribe to my YouTube channel. And I'm going to see you next time for, 3 more videos on bonding and molecular structure. Bam!